What's up, everybody? Okay, so it's been a while since I've done a video, but essentially in this video, what I'm going to be talking about is how I wired in my DB on my testing board for my miniature installations. So in this video, I'm essentially going to show you the inner workings of my DB. I'm going to explain everything to you as to how my dad and I wired it in, how it works, etc, etc. So without further ado, let's get started. Okay, so this essentially is my power supply for my testing board. Okay, so I'll show you my testing board in a minute, but essentially my testing board is meant for installations, right? So miniature laboratory installations, if that makes sense, right? So I can build stuff on my board to simulate an installation, if that makes sense. So that's the purpose of the board. This panel, or this DB, is essentially three-phase. Now, the reason it's three-phase is because my whole house is supplied by three-phase electricity. There's a whole story as to why that is, but we don't have to get into that. The important thing is that this DB is fed from a three-phase power supply. So let me show you the inner workings of the DB. Okie dokie, guys. So for the purpose of this section of the video, I'm not really going to show my face because I want to show you everything on the panel itself, right? Or the DB. So first things first, this isn't connected to the main power supply yet. I'll show you how it gets connected, but in essence, nothing here is live. So we can essentially touch anything here. And I won't get shocked in that sense because it's not connected to the main power supply. So I just wanted to let you guys know I am safe to essentially show you what's the inner workings of the board. Let's start, right? So essentially what we have is we have our three-phase isolator. We've got our single-phase isolator. We've got our ELCB circuit breaker. And we've got a normal circuit breaker. Right, so the ELCB and the normal circuit breaker at this current moment in time is not connected to anything. Reason for that is because there's nothing on the board currently for us to connect the circuit breaker to, if that makes sense, right? But for the purpose of this video, I'll just explain to you the three-phase and the single-phase isolator, right? So, like I said earlier, this panel is supplied by three-phase electricity in that sense, right? So we've got our cable here coming in through the DB and into the three phases, right? So this is a three-phase cable, or each live phase is connected to L1, 2, and 3, right? So you've got live 1 on L1, live 2 on L2, live 3 on L3, if that makes sense, right? Then obviously you got your neutral connected to the neutral bus bar, or the neutral bar in that sense, right? So the question comes is, okay, so from the three-phase isolator, how do we get power to like miniature single-phase installations in that sense, right? So that's where the single-phase isolator comes in. So the single-phase isolator is essentially connected to L1 of the three-phase. You can see here, essentially, we've got our L1 wire. I don't know if you can see that properly, but we've got our L1 wire coming into L1 of the three-phase isolator, right? But essentially what we've done is we've taken the L1 and we've bridged it to the live of the live terminal of the isolator, or the single-phase isolator. Right, so that's how we've now essentially got power to the single-phase isolator. Now you might be asking yourself, okay, what about the neutral, right? So the neutral, we've also connected to the neutral bus bar. So the neutral, in that sense, that's connected to the single-phase isolator, we've just connected to the neutral bus bar. Why do we do that? Because the three-phase cable neutral is connected to the neutral bar. And then from the neutral bar, the neutral then feeds into the single-phase isolator. All right, and then what else can I explain here? So I did explain the LCB and the circuit breaker. right? At this current moment in time, they're not connected to anything because I still have to build something to connect these two things to, in that sense, right? But in essence, the only other thing I can explain to you is the earthing bar at the bottom here, which is connected. So you can see here, you've got your earthing, connect your earthing from your 3-phase connected to the earthing bar in that sense, right? So I just thought that's something I should mention. But yeah, basically this is the inner workings of my distribution board for my laboratory test panel. So yeah, so that's the inner workings of the DB board itself. This is how my dad and I wired it. Obviously I did it under his supervision. My dad is qualified. And so yeah, that is how we did it. Sorry guys, I just wanted to show you quickly my whole testing board. So you can see here, that's the board itself. All the drawings over there is essentially what I'm going to do later on. But essentially, I just wanted to show you how the board essentially gets power, right? So like I explained, the panel or the DB board is supplied by 3-phase electricity. We've got our cable running there down to a 3-phase socket outlet, right? So you can see here, that essentially plugs into the 3-phase socket outlet, which is connected to the main power supply of the house, right? So essentially, if I want power to the board, I plug that into there, and then I get power to the board. So maybe I should actually show you, when it is plugged in, essentially the power I get from the board. Okay guys, so essentially what I've done is I've plugged my DB into the main power supply. So now essentially we have power supply to the board. So there are live components here on the board itself, right? So just for safety, don't do this at home. I'm probably a very bad example because I did it at home, but I'm studying the electrical trade in that sense, right? So, but again, yeah, don't do this on your own. I've got my dad supervising me currently. He's over there. He's just not saying anything. But essentially, we have power to the board, right? So I'm going to test with my multimeter just to show you the values that I get and also just explain a little bit about that in there. Right. So I've got my multimeter here. I've got a clamp multimeter. And essentially what we're going to do is we are going to measure voltage, right? I would measure current, but currently, I don't have anything built onto the board. I can measure the individual wires there, but for the purpose of this video, I'm just going to measure voltage, right? So what we do on my multimeter, we essentially turn it to voltage. Now you can see here, essentially it indicates DC, all right? So we're not measuring DC current, we are measuring AC current at this given moment in time, right? So then we just select, and now it's on AC, right? So what we're going to do, we're essentially going to measure from L1 to neutral, L2 to neutral, L3 to neutral, and then we're going to measure between phases as well. Okay guys, so what I've done, essentially, you can see here, I'm not measuring current, by the way. I've just essentially hooked my clamp multimeter onto my cable so that I can use both my hands and both my probes to measure the voltage of the board. Okay, so that is why it is clamped on the cable. It's not to measure current, but it is to measure voltage. Or I'm not clamping it to measure voltage. I'm clamping it so that I have my hands free to measure the voltage on the board itself, right? So like I explained before, we're going to measure between phases. So L1 to L2, L1 to L3, L2 to L3, in that respect, that kind of thing. All right, so we're going to measure between phases. And what we're going to do is we're going to measure each phase to neutral, right? So let's do that, right? So from L1 to neutral, we are getting 235 volts, right? So that's 235 volts, which is in spec because that is like single phase stuff. Even though I'm measuring it on the 3-phase isolator, 1 phase to neutral will be about 230 volts, right? So if we do the same with L2, we can see we're getting 239. So again, in the spec of like their 230, 240 range, which is normal for one live to a neutral, if that makes sense, right? And then if we connect, or if we just measure L3 to neutral, we get 238. Okay, so yeah, live to neutral, or one live to neutral, will give you about 230 to 240 volts in that respect, right? Now we're going to measure between phases. So if we measure L1 to L2, what we're getting on the multimeter essentially is 408 volts, right? So as far as I'm aware, I'll ask my dad for clarification, but as far as I'm aware, if you measure between phases, you should get about, I think, like 410, 420, if I'm not mistaken. But again, don't take my word for it. I am still learning. I am an apprentice in that sense. I'm just making these videos not for educational, for entertainment purposes, right? But I'll clarify with my dad, because my dad is qualified. But essentially, if we measure from L1 to L2, we get roughly in the range of 408 to, or you should get between like 410 and 420, if I'm not mistaken, right? So again, if we measure L1 to L3, we get about 409 volts, right? Now if we measure L2, we get 411 for L2 to L3, right? And if we measure L2 to L1, we get about 408, right? So that's how, like, you measure, maybe not completely how you measure 3-phase, but that is essentially what I've been taught so far on how to measure and read 3-phase, right? So without further ado, yeah. By the way, because the isolator is off, or if it's essentially switched off, the bottom terminals here aren't live, right? So if I switch that on now, you can see there it's red and it's on. I can essentially measure these 3 terminals, and they'll also give me a reading, right? Just something to note. Yeah, so just for safety, we switch it off. But yeah, now what we're going to do is, for extra safety, because we're done measuring, we just disconnect it from the 3-phase power supply. So also another thing that I want to show you is another measuring tool that I like, but it's, I won't say risky, but it is a nifty tool, but I wouldn't rely solely on it. I would rely mostly on my multimeter. But essentially what I have here is a voltage and current non-contact tester, essentially, right? So what this does, I'll show you in a minute, but essentially it is supposed to detect if there is voltage and current present, right? The downside to this thing, or downside and upside, is the upside is essentially it tells you if something is live, and it tells you if there's voltage. However, the disadvantage is it doesn't tell you how much. So it can indicate voltage, but it doesn't say whether it's high voltage or low voltage in that sense, right? So this, I won't rely heavily on this thing. I'd rely more on my multimeter, but just to show you the purpose of this, I'm gonna show you. So if you see here, it's rated for Cat 3, and essentially you can see their voltage, right? So this whole area is the voltage section. And if you switch it over, this whole area is the current section. So this measures current, this measures voltage. So if you see here, you've got a little switch. So I can now switch current or switch to current, and I can switch to voltage as well. So you can hear it beeping. That's also another thing about this tester, is that it can beep randomly even if there's no voltage or current. Like you see, I haven't got it near anything, and it's beeping, right? So again, rely on your multimeter for proper testing and to get proper values, right? But essentially, we've now got it set to voltage. So if I show you what it does, essentially, right? You hear that? So now it's indicating, because the board is live, right? We've got current and voltage. We've got voltage supplied to the board, and we've got current flowing through the board, or through the DB in that sense, right? But essentially, you can see here, you can hear that, right? So now what it's doing is it's indicating that there is voltage present, right? Yeah. So that's in essence how it works. Okay guys, so we've got our 3-phase socket outlet here that essentially supplies power to the board. So now I'm going to show you how I disconnect it, right? So it's pretty straightforward. Lift. And righto guys, okay, so I hope you found that entertaining. Yeah, just to show you essentially what I've been doing in my spare time. Another thing to mention is the reason I built this laboratory test board is to essentially simulate what I do at my institution, my college, because I'm doing my trade. Obviously, that's why I've got the board, is to simulate everything that I do at my college, essentially. So I hope you guys found it entertaining, and I'll see you in the next video. Cheers, guys.